the practical all about infrared radiation. We're going to get you totally prepped for those top marks. Think of this as a competition, matte black versus shiny silver. Which one is the ultimate radiation champion? We're going to put them head-to-head to see which is best at both giving out heat and taking it in. And trust me, by the end, you'll know the winner and exactly why they won. But before we get our hands dirty with the experiment itself, we've got to cover a few key ideas. Okay, so what is infrared radiation? Well, think of it as invisible heat rays. It's a type of wave that carries thermal energy from one spot to another. And the amazing thing? It can travel through a total vacuum. Yep, empty space. That's how we feel the heat from the sun, which is millions of miles away. And it's not just the sun. Literally every single object with any heat at all is giving off and taking in this radiation all the time. Right, so this practical looks at two sides of the very same coin, emission and absorption. Emission is just, well, giving out heat. Think of a hot mug of tea cooling down. It's emitting infrared radiation. Absorption is the opposite. It's taking heat in. You know, like when you wear a black t-shirt on a sunny day and you feel yourself getting hotter. That's absorption. And we're about to find out which surfaces are the champions at doing both. So for this experiment, we want to see which plate heats up the quickest. Our heat source is a radiant heater, which pumps out lots of infrared radiation. Now, the absolutely crucial control variable here is making sure every plate is the exact same distance from the heater. That way we know they're all getting hit with the same amount of radiation. And when we look at the results, we see a really familiar pattern, just happening in reverse. The matte black plate gets hotter faster. It shows the biggest temperature jump, which means it's by far the best absorber of infrared radiation. And that shiny silver one, it barely warms up at all, making it the worst absorber. So when we put all this data together, we get a really simple, powerful conclusion. The best emitters are also the best absorbers. Matte black takes the crown. This actually links to a really cool idea in physics called a perfect black body. It's a theoretical object that's a perfect absorber, and because of that, it's also a perfect emitter. And the flip side is true too. Things that are bad absorbers, like our shiny silver surface, turn out to be great reflectors. Okay, so knowing the physics is one thing, but let's talk about how you turn that knowledge into top marks on your exam. What kind of flaws or potential slip-ups in the method might they ask you about? Examiners absolutely love asking about this stuff. Things like parallax error, that's just a fancy way of saying you need to look at the thermometer straight on at eye level to get an accurate reading. Mentioning that shows you're thinking carefully. And of course, the golden rule for pretty much any science practical, repeat your experiment and calculate a mean, or an average. It's the best way to spot any weird results and make sure your conclusion is reliable. Here it is, a classic real-world application question. This is where they test if you can take the conclusion from your practical and apply it to a situation you might actually see. So how would you use what we've just learned to bag all three of those marks? Look at this structure. It's a perfect three-step recipe for getting all the marks. Step 1, give the direct answer. Paint it matte black. Step 2, give the physics reason, because matte black is the best emitter of infrared radiation. Step 3, link it back to the question, so it will heat the room up most effectively. Okay, let's do a quick recap and see how this all connects to the real world. Seriously, it's everywhere. From the radiator that keeps your house warm to the cooling fins on an engine that stop it from overheating. And on the flip side, those shiny emergency blankets and the inside of your flask are designed to be poor emitters to keep the heat exactly where you want it. So let's really think about that space blanket. We know a shiny surface is a terrible emitter, right? So it's not going to radiate your body heat out into the cold air. But here's the kicker. If it's a bad emitter, it must also be a bad absorber. And if it's not absorbing or emitting well, what's left for it to do with that heat energy? Reflect it. That shiny surface acts like a mirror for your own body heat, bouncing it right back at you and keeping you warm. It's the total opposite of a radiator, but it's all explained by the exact same bit of physics we've just investigated.